Hi guys. Today we are doing law of sines. Before we do law of sines, we're gonna start by finding the area of a triangle that we are given, because this kind of ties into something you'll possibly be doing in pre-calculus. Okay, so finding the height of a triangle is really important. We need to find the height of a triangle in order to find the area, because area is equal to 1/2 base times the height. Okay, so you need to be able to find the height of a triangle. All right, so if you've got a triangle, triangle ABC, and remember, this is side length B, this is side length A, and this is side length C. Okay, the height of the triangle, you can use as any, not any line, but it can be from any vertice, okay, or vertex. I like to do it from the top vertex to the bottom, but it has to be a perpendicular line to the opposite side length. Okay, so if you're taking the height from angle B, it has to be perpendicular to side length B. If you're taking the height from C, angle C, it has to be perpendicular to side length C. Okay, and if you're taking it from A, angle measure A, it has to be perpendicular to side length A. Okay, and if it's obtuse, if it's an obtuse triangle, something like this, okay, again, your height can be from any angle, but if it's from this particular angle, it has to be perpendicular to the extension of this side length. Okay, it has to be perpendicular to that extension of that side length. Okay, and that's all you have to remember. But normally I like to have it inside of the triangle. So let me erase these. That way I can just use one of them. Okay, so that's going to be my height of the triangle. So how do you find out what H is? Okay, so the reason you have to find out what H is in order to identify the area is because this is not a right triangle. We're not working with right triangles today. Okay, we're not working with right triangles today. So the reason we are doing this height is to create a right triangle inside of it. That way we can use sine, cosine, and tangent, because you cannot use sine, cosine, and tangent if you're not working with a right triangle. Okay, because to use sine, cosine, and tangent, you have to have opposite, adjacent, hypotenuse. Okay, but in non-right triangles, there is no hypotenuse because there is no right angle. Okay, so you need to be able to create a right triangle in there in order for you to use sine, cosine, tangent to identify what your height is. Okay, so since our new right triangle is right here, okay, I can find my height because if my theta is right here of my big triangle, okay, my theta is there, the height is the opposite side length, and then C would be my hypotenuse. So you can use sine of theta or sine of A to find your hypotenuse, because your your h, because your h would be over c since c is your hypotenuse. Okay, opposite over hypotenuse. So to find h, you just multiply both sides by c to get height equals c times sine of A. Okay? All right, so let's do the first example. It says find the area of triangle PYT. So we've got triangle PYT here. Okay, so this is T, this is little y, this is little p. It says that angle P is 73 degrees. T is 2.9 meters and little y is 1.9 meters. Okay, so this is what you're given. It says find the area. Well, we know that area is 1/2 base times height. Okay, so I'm going to create a right triangle in here because I'm going to make my base this one. Okay, so if that's my base, that means my height has to be perpendicular. Okay, so I know my base is 1.9. Now I need to find my height using sine of 73. Okay, so I know sine of 73 equals height, which is my opposite, over hypotenuse, which is the 2.9. Okay, and again, that's the hypotenuse of this right triangle that I created inside of the triangle I'm finding the area of. To find the height, I'm going to multiply both sides by 2.9. So I'll get 2.9 times sine of 73. Okay, I'm going to make sure that I am in, in degree mode. Okay. So 2.77, and actually in my notes I didn't even write that. I just wrote my height as this. Okay, so now that I have my base and I have my height, and again I'm just calling my height this, that way I can get the most exact answer instead of rounding that decimal that I just got. I'm going to do 1/2 times my base, which we said is 1.9 because the height is perpendicular to that, times 2.9 sine of 73. Okay, now I can put that in my calculator. So 1/2 times 1.9 times 2.9 sine 73. And I will get 2.63 meters squared. Okay. All right. Number 2, example 2. It says find the area of triangle WHS. Okay, so we've got WHS. Okay. All right, so this one is oriented a little bit differently. Our base will not be perpendicular to this, okay, because we're normally used to having a base down here, okay? But remember, the base can be any side length as long as the height is perpendicular to it, okay? So personally, I made my height from H. If you want to make your height from S, go for it. Okay, If you want to make your height S, go for it. I didn't draw this to scale. Okay, but I'm right there, let's say, and this would be your height. Okay, therefore your base would be the 5 meters. Okay, so again, I am going to use 3 meters as my base. There's just more room there and it looks better. Okay, so I'm there. My base is 3, but I can find my height by doing sine of 40 equals my h, my height, over 5 meters, because that is my hypotenuse. Okay, so I'll multiply both sides by 5, so I'll get my height to equal 5 sine of 40. So that's my height. My base, we said, is 3 meters, so 1/2 times 3 times 5 sine of 40 will equal my area. And that will be 4.82 meters squared. Okay? All right, so that's how you find area. Now let's move into law of sines. So law of sines is a rule used to solve triangles that are not right triangles. Okay, so you can still use sine when you're solving oblique triangles, non-right triangles. Okay, but you have to use it in a certain way. Like you can't say sine is equal to opposite over hypotenuse. You can't say cosine is equal to adjacent over hypotenuse. Okay, there's a certain law, and the law of sine, it's a formula. You're going to, they're basically proportions and ratios equal to each other. Okay, so if you have triangle ABC and side lengths little a, little b, and little c, okay, you will use this formula. Sine of a over little a equals sine of b over little b equals sine of c over little c. Okay, or you can flip them. You can say little a over sine of big A equals little b over sine of big B equals little c over sine of big C, as long as they're all flipped. Okay, either one. So that is the law of sines. You use law of sines for AAS triangles and ASA triangles. Okay, remember that? So AAS triangle would be like if you had an angle, another angle, and then a non-included side. Okay, so that would be AAS. ASA would be an included side. So you'd have this angle, an included side, and then the angle on the other side. Okay, so you use law of sines for AAS and ASA triangles. You can also use them for SSA triangles, but if you look ahead in the notes, that is the ambiguous case. So we're actually not going to do many SSA triangles, and we're certainly not going to do the ambiguous case here. You will do it in pre-calc though. Okay, the ambiguous case says that for SSA triangles, you can either have 1 triangle, 0 triangles, or 2 triangles if you're given a side, and then an angle. Okay, but like I said, we're not going to do too much of that. And we're certainly not going to do ones that give you two triangles. Like I said, that will be covered in pre-calc for sure. Okay, so let's move on to doing some examples using law of sine. So the first one is solve triangle RST. Okay, and when it says solve the triangle, it means find all missing side lengths and angles. Okay, so if it gives us this triangle, we are looking for side length T, angle T, and side length S. Okay, we're finding all three of those. When it says solve a triangle, it means find all missing side lengths and all missing angles. All right, so the easiest thing whenever you're given something with two angles already is to find the third angle because of the angle sum theorem. Okay, all the angles of a triangle add up to 180 degrees. So I can say that angle T plus 50 degrees plus 70 degrees will equal 180 degrees. Okay, so angle T is going to equal 60 degrees. Okay, easy. All right, now that we've got that, we have to use law of sines. Okay, and in law of sines, the easiest way to go about this, and really the only way to go about this, is to decide what full ratio do we have. When I say full ratio, I mean this is a full ratio. You have angle A and little a. Okay, when I say full ratio, I'm talking about, do you have the angle and its opposite side length? Okay, this is a full ratio when you have angle B and side length B. Okay, so what full ratio do I have? What angle measure do I have that I also have its opposite side length? And that would be R. Okay, so I can say sine of 50 degrees, which is my angle measure R, over 10 equals, and now I can look for either S or T, little s or little t, because those are the two things that I'm missing, and I can find either of them first because I have both of their opposite angles. Okay, so I'm going to find side length S first. So sine of 70 over S. Okay, how do I find this? You can cross multiply. Okay, so if you cross multiply, you'll get S times sine of 50 equals 10 sine of 70, and then divide by sine of 50 to get S to equal 10 sine of 70 divided by sine of 50. Put that right in your calculator. Let me just make sure that's right because I can't remember. 10 sine 70 over sine 50. Yes, okay. And we get 12.27. So S, little s, is 12.27. Okay? And then, whoa. This is 12.27. Okay, and then I can use law of sine again. Okay, I can use law of sine again to find little t. And again, I'm going to use my given full ratio. And I'll put 10 on top this time. Sine of 50. And really doesn't matter. You don't have to put 10 on top. You could put sine of 50 on top. Like I said, it doesn't matter as long as you do it for the other one as well. Okay, so this will be t over sine of 60. Okay, and in this case, I don't have to cross multiply. I can just multiply both sides by sine of 60 to get t equals 10 sine of 60 over sine of 50. And put that in my calculator. And I'll get 11.31. And my triangle is solved. Okay? Next one. The law of sine can also be used to find the measures of missing angles. Okay? So solve, let's see, I am given, okay. So I've got this triangle WHS. And I'm given this angle, 48 degrees, and then I'm also given this side length and this side length. It was just really hard to write in from the computer on that. So I just kind of gave it to you right now. So that's given. So as you can see, this is an SSA triangle. How do we know that? We got a side and then an adjacent side and then an adjacent angle. Okay, SSA. Some people say ASS. Whatever, I don't care. Okay? Think of it as ASS. That's the bad one. It's the ambiguous case. But like I said, we're not doing the ambiguous case in Algebra 3. So this one will only have one triangle. We're not going to have to test if it's no triangles or one triangle. This one will have one triangle and one triangle only. Okay, so we don't have to get into the ambiguous case. All right, so we're going to solve this the same kind of way. We're going to use law of sine. You don't have to think about any weird things going on. Okay, just use law of sine like normal. We are going to be looking for little s, for little s, big W, and big S. Okay, and we're going to be using law of sines. As you can see, we're only given one angle measure, so I can't find an angle measure first. Okay, just by using law of the sum of triangle sum theorem. Sorry, I can't use triangle sum theorem first. I have to use law of sine. Okay, so what full ratio do I have? H. Okay, so I can say sine of 48 over 10 equals sine of W over 8.2. Okay, so that will give me angle W. Okay, so angle W I'm going to multiply both sides by 8.2, so I'll get sine of W equals 8.2 sine of 48 over 10. How do I find sine of W? Well, this goes back to inverse trig. Remember how inverse trig, when you're looking for an angle measure, what do? You take the inverse sine. So we're going to be taking the inverse sine of 8.2 sine of 48 over 10. So that's how you would solve for missing angle. Okay, so that's exactly what you would put in your calculator. Okay, so inverse sine of 8.2 sine of 48 over 10. And that'll give you 37.5. Okay. And now that you have that missing angle measure, you can use the triangle sum theorem to find S. Okay, so 180 minus 48 minus 37.5 is going to equal 94.5. So this will be 94.5. Okay, so that'll be 94.5 degrees, and then all that's left is to find little s, and again, I'm going to use law of sine with my given ratio again. So I'm going to put 10 on top this time because I'm looking for a side length. So 10 sine of 48 equals little s over sine of 94.5. So I'll multiply both sides by sine of 94.5. Okay, and that's what I'll plug in my calculator. And I get 13.4. So this is 13.4. Oh, excuse me. Okay.